we're going to begin the second kind of transformation, reflection. A reflection is a point or set of points in a geometric shape that is reflected or flipped over a line. For now, that line that we are going to reflect over is called a line of reflection, and it will usually be the x-axis or the y-axis. When the line of reflection is one of the axes, then each point that you're reflecting is the same distance on both sides of the line for each point. So let's say A is 2 points to the right of the x-axis. Then you're going to count 2 to the x-axis and then continue counting 2 more in the same direction so that it is still 2 places but on the other side of the line. Our lines of reflection, we will start with simple ones over x and y axis. It is possible to reflect over a different line, and I'll talk about that here in a moment. Again, with reflections, just like in translations, both the pre-image and the image are congruent. The size and shape of the figure should not change. It should be the same. Corresponding angles are going to be congruent, and corresponding sides are going to be congruent. However, they will not be parallel. Okay, because a reflection is, take a piece of red construction paper, fold it in half, and you're going to trace half of a heart on the fold line. Okay, then you take your scissors and you cut that heart out. When you unfold that heart that you cut out of on the fold side, you only cut 1/2, but as you open it up, you have a full heart. So on the left side of the fold line could be your pre-image, and when you reflected that over the fold line, those same points on the left side are on the right side the same distance away from the fold line. Okay. It is possible to reflect over other lines. There's a rule for reflecting over the x-axis. Anytime you reflect a point or multiple points over the x-axis, when you start with point xy, you're going to leave the x coordinate alone, and y is going to become the opposite. So if you start out with ordered pair 2, 4 here, your reflection point for the image is going to be 2, -4. The x coordinate will always stay the same. The y coordinate becomes the opposite of the original point. If you reflect over the y-axis, so say given point xy, you're going to change the opposite of x, and y is going to remain the same. So if you're given point 4, 4 to reflect over the y-axis, your new point for x is going to become -4, y is still going to stay the same. So your new image point is going to become -4, 4. Again, the x coordinate becomes the opposite of the original point, and the y coordinate stays the same. It is possible to reflect over a given line in an equation such as x equals 3 or x equals -4. We will not get into that too much. That'll be something that you do later on in Algebra 1 and Algebra 2 in geometry. To do so, if you have to reflect over another line, you're going to count the number of spaces from the pre-image point to the line of reflection, then continue counting from the line of reflection the same number of spaces on the other side of the line. Mark your point where you start and make sure it has a prime point. That wraps up reflections for us. Let me know if you have any questions. Thank you.